Hi and welcome to my video on calculating the areas of sectors of circles. So the assumption in this video is that you've already learned how to calculate the area of circles and you have a bit of understanding of angles, otherwise you'll be able to do everything. You'll need to know the number pi and be able to use a calculator, so just don't forget that pi, it's about equal to 3.14 and here's a good opportunity for me to plug the fact that there is an international pi recall competition. How many decimals can you remember pi to? Me? About 5, which is not very good. Anyway, I've got a calculator over here. There's going to be times in this lesson where I have to jump across and use that because I can't do the calculations in my head with pi. So you'll see the video sort of chop and change a bit, but otherwise it should be all good. So here's a circle, first of all. I want to calculate the area of this circle just as a quick reminder. So remember, the area of a circle is equal to pi r squared. And r is our radius. Don't ever forget that. You'll see r is going to be your radius for the next couple of years at least and nothing else. Here I've defined my radius as 3. So the area is equal to pi times 3 squared, which is equal to 9 pi. Now, this is called exact form, which you won't have seen much of, but later on in your mathematical careers, you'll know exact form is actually pretty nice. But in Year 8, you're going to evaluate these. So I've just done that, and it's come out with 28.27 to 2 decimal places. So this is equal to 28.27, and we should also have the units. It's an area, so let's just imagine I call this 3 centimetres, and this is centimetres, and it's an area, so it's centimetres squared. So there's the area of the whole circle. Now that's not what's important today. We want to talk about the area of sectors. This is a sector. It's a bit like a slice of pizza. Okay. Now I've defined the angle inside this sector, and we're going to explore this one first, and then we'll do one other example that's a little bit harder and set up the rule. Okay. This radius is still 3. It has an angle of 60 degrees. So ask yourself this: if a whole circle has a total angle of 360 degrees, how much of the circle is this? Now I've deliberately set 60 up to be a nice number, and if you don't see this straight in your head, that's fine, but I hope you can see that 60 degrees is 1/6 of this circle. Just imagine for a second if I cut it up into those bits. 1, 2, 3, 4, 5, 6. They've all got an angle of 60 degrees in the middle. 60, 60, 60, 60, 60, and 60 hidden there. And that total sum is 360 degrees. So this is 1/6 of the circle. So the area of this one, the area is equal to the area of the total circle times 1/6, or divided by 6, which is the same thing. So in this case, it's pi times 3 squared times 1/6, and that's 1/6 of our answer from earlier. 1/6 of this, which is equal to, I've just done this, about 4.71 centimetres squared. So the trick to doing the area of sectors is to recognise that it's a proportion of the whole circle. In this case it's 1/6, but that's an easy example. So let's talk about a slightly harder example. This time I'll draw my sector, I'll do it over here, and a nice little circle, and this time the angle is going to be 52 degrees, which is a little bit harder, and we'll have a radius of 5.2 metres. We'll make it a big circle. Okay, this is a sector. It's a part of a circle. The trick here is though, 60 divided into 360, 52 is not so nice. This is where the proportion comes in. This is where it gets a bit harder. So let me show you the area. First of all, the area will always be equal to a fraction of the whole circle. And the whole circle has an area of pi times 5.2 squared. It's just what fraction of the circle is it? Here's where the trick comes in. This is where it gets easy, it's very procedural. 52 degrees is covered in this circle, and a total circle is 360 degrees. So it's 52 3/60ths of the whole circle. We get that just from that angle. It's 360 degrees in a circle, we just use that number. That is what we put in our calculator. Okay, so I've just put that into the calculator and it's come out with an area of 12.27. And this is in metres, so it's metres squared. What you need to do is maybe just put that in your calculator yourself. Make sure you come out with the same area, because you've got to be really careful when calculating this. This is a significant area order of operations problem. have to make sure that you get your order right and you don't end up accidentally dividing by pi or 5.2 squared or anything like that. On your Casio FX calculator, you can also determine the area of the circle first and then multiply that answer by 52 over 360 is always a good idea. But make sure you get that 12.27. The last thing I'm going to do is just define the overall rule for you. And so the overall rule looks like this, and I'll write it down here. The area of any circle is equal to the angle in the circle, which I'll just call A, but you will get introduced to the angle theta soon, but we'll just call it A for now, divided by 360 degrees, which is the total angle in the circle, multiplied by the area of the circle, which is pi r squared. And so that is for this sector here, which has an angle of A. And it's that simple, you just got to put it into that formula. So if you get anything from this video, it would be that you can recall and use that formula. And there's a hard example, there's an easy example, and I hope you've enjoyed. Thank you very much.